Okay, so phylogeny is the information that we will be looking at in these notes. Um, and this is a statement of what you should know. And basically, phylogenetic trees and cladograms are graphical representations or models of evolutionary history. So, cladograms first are diagrams, and they group items together based on the number of common characteristics. So the order that this is done is that they determine the number of shared characteristics first and then arrange the items as a tree showing the most common possible. So phylogenetic trees actually use two types of data. So they first will use physical traits, structures that are the same between organisms. And then, and this is obviously something newer, relatively newer in the world of phylogenetic tree making, and that is the DNA and protein sequence data. So they can look at which proteins and which DNA are present in organisms and then use that to determine the order of evolution. So here's an example of vertebrate phylogeny, and this one is obviously very complex, but you can see all of the vertebrates that are listed on the right-hand side, their scientific names, and then there are a series of numbers, and that shows where a different characteristic evolved. So here's a complete phylogeny of organisms, period. So it's around, and you'll see them in different shapes. So the construction is first you determine similarities, and something called a character table works well. And then you arrange those organisms in a tree diagram, and you do that by showing the simplest possible evolution. There's this term called maximum parsimony, and what it says is that all else being equal, a trait is assumed to evolve once. So it will pop up once, and then it will be present in all descendants after that. So using this character table, and because on the previous slide, I don't know if I said it, but character tables work well for similarities. So using this character table that shows various vertebrates, animals, along with characteristics, and the 0 indicates that it is present. The 0 means it's not present. The 1 means it is present. I want you to create a tree. So here are a couple of examples of what I am looking for, and you have a blank slide, and these obviously don't contain all of them that you have, or even the characteristics, maybe some, but not all. I want you to put this on the blank slide that you have on your notes sheet, and keep in mind that these are all hypotheses, as is the whole of evolution, and there are new species being discovered all the time, and therefore these relationships are continually revised, and there are different scientists who will look at them differently, and so from scientist to scientist it could be a different hypothesis. And then there is the role of computers, and if we have data that has been inputted, there are databases that have DNA and protein sequence information for various organisms, and that's what we will be working on today.